Good morning, good afternoon, good evening, depends where you are. Welcome to Microsoft Virtual Academy, practical performance tips to make your HTML, JavaScript faster. I'm Doris. With me is
John David.
We're honored to present this, our favorite subject, performance tuning. Most important thing is let's have some fun. Are you ready to have some fun? I know we are. Okay, so let me actually say a few more things about myself. Again, I'm Doris Chen. I'm a technology evangelist at Microsoft. My expertise area is web technology, so I am a web person. For the past few years, I'm focused on JavaScript and HTML5 technology. Now, I usually publish some technical articles, some demos to my blog, and here is my blog address. But to be honest with you, I don't really remember my URL. If you do a search, Doris space Chen, and then MSDN, you could use any of the search engine. The top two links, one of them will be my blog address. So you could actually get my blog from there. As an evangelist, I also speak internationally on web technology, on different performance, HTML5, and different kind of frameworks. So it's really exciting job, and I'm so happy to be here. I have been with Microsoft for about 4 years. Before that, I have been working with open source Java community for over 10 years. So basically, I have been working on the web space for roughly about 14 years. Before that, I spent quite a few years in school, tried to get my degree. I have a PhD in computer engineering, focused on medical informatics. And if you're interested in medical informatics, you could ping me offline. And one more thing, if you want to find me online, try to reach me at Doris T. Chen. That's my Twitter address. Make sure you put a T there, because I don't know who actually took Doris Chen, but you have to really ping me at Doris T. Chen. Okay, enough about me. We're so fortunate to have JD here with us. So
Hi.
JD, would you like to introduce yourself?
Sure. My name is John David Dalton. I am the Chakra Performance PM. Chakra is the JavaScript engine in IE. I'm also an open source contributor, so I work with projects like Lodash, JSPerf, which is a benchmarking site for developers, Benchmark.js, which is the JavaScript library that measures the performance in JSPerf, and various other open source projects.
Okay, thank you, JD. Okay, so let's actually talk a few things about today's course. If you look at the title, it seems to suggest it's a 400-level course. But actually, we do have some 400-level content, but it's really targeted for all web developers at all levels, because we're going to share with you the best practice, the tips and tricks that will help you to be a better coder, as well as we'll share with you some other optimization techniques so you could apply to your real work. So here is a suggested tools or browsers in case you want to try the demo with us, IE 11 above or any major modern browsers. It's a natural choice for us to use Visual Studio, but feel free to use your favorite editor as well. A lot of you probably will ask, where are the slide deck? So here is the URL for you to get a slide deck. It's actually on OneDrive. We actually keep on updating, so you could get a most updated copy there. The other thing is we will do quite a few demos during the course. So we posted all the demo code on GitHub, so you could access them, and including demo code as well as the demo script as well. So again, if this is your first MVA course, I will tell you you're in the right place. MVA program is super. Actually, it has over 2 million registered users. I have to update my slide. And you could get all kinds of training there. And what's cool about that is, say, if you're busy, you don't have to spend a few hours on that. You could just pick a module and then listen to that. And the way we set up is make it very short so you could fit into your busy schedule. And for this particular course, you could actually earn 50 MVA points for this event. Isn't that cool? So make sure you use this particular link. And again, it's case sensitive. And enter the code HTML, JS, speed tips. So you will be able to earn your credit. And also make sure it will expire roughly a month from today. Okay, so what are we going to talk about in this course? First of all, we're going to start with this particular module, which is Web Performance 101. We want to make sure everybody is on the same page. And next module, we're going to talk about how to measure the performance, what tools you will be using. And then for the rest of 3, 4, and 5, all the modules, we're going to share with you what are the optimization strategies and principles you should be aware of, and what are the best practices you will be able to use in your work. So we'll be actually addressing network requests, the number of bytes downloaded, how to efficiently use media usage, how to doing the smart memory management, how to do the structured markup, how to execute your code well. And then afterwards, we're going to actually talk about be a good coder, write fast and good JavaScript. Last but not least, we're going to actually share with you a case study. It's a casual game. We're going to actually show you step by step by using all the tools, all the tips, all the best practice we've shown you in the previous module. Sounds good? Okay, let's continue. All right, so first thing first, let's actually give you some ideas what is web performance so that everybody could be on the same page. So we're going to talk about what would be optimization strategy and process. We're going to share with you how to avoid some of the common pitfalls. And exactly, you may ask, what to measure? What tools should I use? And then we will actually roughly talk about what kind of web runtime architecture or environment you're dealing with. So it will help you to understand the rest of the module. And then we're going to share with you what's the difference between, we said, it's a website application versus it's a Windows app. Okay, so let's start with optimization strategies and process. Now, a lot of people usually tell me, they say, oh, Doris, this is a performance tuning course, right? So if you could tell me A, B, C, then I could make my application run much faster. Well, unfortunately, I wouldn't be able to tell you exactly A, B, C to make your performance much better. But I can share with you is a development and optimization process, which we use, all the product team using at Microsoft to make the performance much better. Now, do not think about the optimization process is really in addition to your development lifecycle. It is actually part of your development cycle. So, for example, you're getting a new project from a customer, and first you start with doing the analysis, try to do your design, architecture design, decide which framework, which library you will be using, and then you get into the fun part, which is coding. Right? That's the time you should actually use all the best practice, tips and tricks we shared with you in this course, as well as you learned somewhere else. And then after you finish initial coding or prototyping, then you go into the next level, which is you could start with a single user performance test. Now, it is very important because you want to know what is the performance criteria, right? So say, for example, criteria will be for single user. If you click on a button, then you will actually need to make the page to show within less than 2 seconds. If you fail that test, then you know that might be something wrong. But again, you should always set up a performance criteria ahead of time. All right, so let's do the test. Say if we pass, wonderful. Everybody is happy, move on to the next step. But what if you fail, right? Now, that's the time you should not guess, right? You should use the profiling tools to find out where might be the bottleneck. And once you determine your bottleneck, you will go back to think about all the best practice, all the tips and tricks, and all the better algorithm, and to apply onto your code and to see if you could fix the problem. Then do the single user test again, and this time you say, great, I passed. Then very nice, you could move on to the next level, which is for multiple user test scenario. If not, you have to go back, measure, find a bottleneck, applying all the good things again, and repeat a test. Until you pass the multiple user test, then you pass to your QA, and then if everything is okay, then you could ship it. If not, still go back to the tools to measure, to determine the bottleneck, and then applying all the good things onto it. Now, for this particular course, we're going to focus on the area which shaded in red, which is share with you the best practice, all the strategies and principles, and how to use tools to measure, and then how to actually, you could tune your application to be much faster. Okay, sounds good? So I hope you could actually use it after you go back for your real work. So next, we're going to share with you what do we mean common pitfalls, right? Everybody, has some kind of what we call common sense, but what your common sense might be common pitfalls. So these are the 4 areas we want you to watch out. Speed is not free. Avoid premature optimization. Never guess. And last but not least is your mileage might be different. Okay, so let's take a close look at what do we mean speed is not free. Really, speed is not free. It is really a balancing of act. It is on one end, you have to worry about your performance and the scalability, but on the other hand, you still have to maintain all the good things you have been taught about, which is reliability, the usability, maintainability, extensibility, and code reusability as well as portability. So do not try to just say optimize just slightly on the performance or scalability, but you forget all the good things you already have in your code. So really it's a balancing of the act you really need to watch out. So that's the first common pitfall. Next common pitfall is avoid premature optimization. Now, you should always write clean, clear, and maintainable code. This is really a good practice, right? Now, like I said in the beginning, in the process, you should set up your performance criteria so that you know your criteria. But make sure you test it under your normal production environment. Do not try to think about a really extremity case, right? Some people sort of like try to develop a habit, always over-optimize everything because they always think their code is not fast enough. But hey, if you satisfy your performance criteria, if your end user is happy with that, go ahead, ship it. Because everybody's happy, right? You don't have to over-optimize it. So when the user finds it's too slow, then go back, optimize it. So avoid premature optimization.
So with this writing clean, clear code, when you prematurely optimize, part of that balancing act is when you optimize your JavaScript code, you can make it less readable because you have to get down to the bare metal bits of the language. You can't abstract away a lot of the functionality. And so by avoiding the premature optimizations, you can keep that readability up, you can keep the reusability up, and only have to really dig down into the guts of the performance whenever there's a real issue, whenever there's a real bottleneck.
Very true, because it's not worth it to just optimize the last 1% but lose all the good things you already have. Yeah. True, very true. Okay, let's actually talk about the third common pitfall, which is do not guess. I know everybody think, you're smart, we're smart. I actually the one who developed this piece of code. And if it is slow, then I probably will know the best where might be the bottlenecks. Okay, so here what you're doing is you use your engineering or whatever we call intuition, right? But most likely, if you truly use the profiling tools, you will be very surprised to find out that your intuition is probably wrong. That's not where the bottlenecks are. So you really have to use a scientific way to attack the problem, which is using tools to measure to find out your bottlenecks. Do not guess. All right, so this is very important because including me, I usually make this mistake as well. Okay, so your marriage is different. This is also very interesting. So you're probably going to see quite a bit benchmark data, hard number from this course, as well as you read from magazines, some online articles. However, you should never overtrust the hard number that was presented in the benchmark. You should always try that benchmark in your production environment. Then you probably ask me then say, hey, what's all the benchmark for if it's really, I still have to test it? Well, all the benchmark will give you an indication and direction to show you, say, which library would be better than the other, right? But then exactly how much better is up to you to test it in your production environment. So really, I want to emphasize test in your production environment because your data, your benchmark will be different from ours.
So basically, don't take our word for it. Validate what we're saying and measure on your own machines.
Very true, very true. Okay, so next question is what to measure? What I need to take care in my particular code. So first thing is very important, which is how fast we could get content loaded. Right? So if you look at this diagram, there are multiple factors could contribute to that network loading time. Now, oftentimes people worry about their data plan is not fast enough, the bandwidth is not fast enough. So if you look at this diagram, it shows you for different carrier with different speed of network and show you what exactly the bandwidth. So really, if you could get your bandwidth up to say 5 megabits per second, this is actually pretty good. It is good enough. So you should not worry about that. Now, there's some other things we may need to worry about. So I'm actually going to talk about what is network latency. Now, I actually need JD, your help. Let's do a quick demo. Okay. So JD, follow me. When I clap, you respond to my clap, okay? All right, so you hear JD responds to my clap, but you did hear some delay, isn't it? Right? So then that depends on when JD heard my clap and responds in such a way. Okay, let's try one more time. Follow what I do. All right, now I clapped twice, right? So basically, I double the bandwidth. However, you still hear some delay from JD's response. Why is that? That's because it still takes that much time to really travel over the network. This is a network latency. So regardless how good your bandwidth is, you still have to deal with the network latency. So in the rest of the courses, we're going to show you how to reduce the network downloading time and how to make sure your app, your page could show up as quickly as possible. So network latency does impact your performance. So next, we want to share with you is then what particular parameter we should look into in terms of speed and responsiveness, right? So let's take a look at this particular diagram. So before we do that, we want to actually talk a little bit about real and perceived performance.
Right, so this is where I'll step in.
Okay.
A lot of times, performance is just perceived page load time. So even though the page isn't fully loaded, the time till you can see the first indication of something is really important, because if a user is looking at the page and it's blank for 3 or 4 seconds, they'll think that maybe the page froze, maybe it's unresponsive, they'll try to reload the page. So the time to get something to the screen is very important. So even if the page isn't fully loaded, even if part of the screen loads, that's the perceived performance. It looks like and it appears like it's loading faster.
Cool. Let me actually just add a little example for the perceived performance. So a classical example I usually say will be a progress bar, right? When you're downloading something, you see the progress bar. right? And usually you see from 0 to 99% is like zoom, really, really fast. But seems like it takes forever to get a last 1% downloaded. Why is that? This is really a trick of perceived performance because it's human sort of like a nature. You already get a 99% downloaded. You couldn't wait for the last 1% to download. So even though it does take a little while to get a download, but you're willing to wait. So this willingness to wait is your perceived performance. You have to make sure people always think your site is responsive. There's something there. It's not dead. Right? And really, the whole trick about a CPU utilization is if you look at the CPU time here, it's actually less than the total page loading time from beginning until the end, right? So there's a little idle time there. So really, our job is try to push everything towards the left, meaning make the page loading time as short as possible. So how should we do that? Reduce the CPU time, but improve the parallelism. And this is a key concept we're going to actually talk again in the rest of the course. All right, so the next we want to actually address is the memory utilization, because memory is actually very crucial. It's very critical. Right, so if you look at this particular diagram, you will see we actually plotted this diagram, which shows roughly about 5,000 sites with the graphical decoding. And you do see actually there will be some sites they use up to 200 megabytes of memory in order to getting their graphics decoded, just for the graphics decoded, right? But if you think about it, 200 megabytes, maybe not too bad if you have an application running on desktop. But what if you have a very low-end device, low-end cell phones? 200 megabytes, maybe it could afford, right? So you can actually slow down your performance if you have such a high memory utilization. Now, even with a low range of memory utilization, say I have 20, right? I'm using 20 megabytes, no big deal. But hey, if you think about you have 20, that's megabytes for each of a tab on the browser running on a mobile device, then you could actually have multiple tabs. Each tab is 20, you do the math, it's going to accumulate to quite a big number. So again, the memory utilization is actually another crucial factor which is going to impact how fast your sites and apps. So be careful about the memory management. We will talk about that in more detail later. Next, which is interesting. So we all have all kind of apps running on different tablets, mobile devices, or even your desktops. So power consumption is so important to address. It's basically, it's your battery life, right? So let's take a look. So 3 factors are really contributing to the power consumption. VSync. VSync is basically the signal from the monitor, and because the hardware limitation, so you could only get up to 60 megahertz per second. That's actually your eyes could really catch up. And then you see, first I have all the resources loaded, including image. And then, this is pretty good, I actually have a big sort of like a break here, right? Meaning, I'm not doing anything, and then I could continue. So when you're not doing much, this is good, because then you could save some power there. But in real life, it is maybe not true, because say you're running a game and they have some live ads, then there are quite a bit of things going on in the background. So you could still see something going on here, which is going to keep on consume your power. So basically, one simple rule is rest the power. Make sure you don't have too much background things going on. Then at the same time, use as less as CPU utilization, and then the GPU utilization as much as possible. Because you may say power consumption, that's not for speed. Very true, it's not for speed. However, it's really for the efficiency. It's for the satisfaction from your end users. Let me give you a quick example about mobile device, low-end mobile device. A lot of times, you probably could use up to 5 watts. Afterwards, your device would become extremely hot. That's what we call thermal mitigation, right? You reach that threshold. Now, you say 5 watts, that's a lot. But actually think about it. If I'm downloading a map from the web. And easily, I could actually using GPU, right, for 2 watts. And then I'm engaging with maybe more than 1 core in the device, another 2 watts. And then you could say, oh, I need to use antenna, right? I need to get the map data. So that's another 1 watt. So here, you already engage 5 watts already. Once your device becomes extremely hot, that means you cannot do much. You cannot even recharge the battery, right? So basically, your user will say, the rest of the app are not working. So this is really something very important. You really need to watch out all these 3 things, like the UI responsiveness, the GPU utilization, as well as CPU, because it directly really impacts users' satisfaction.
Another point on the power consumption and performance, a lot of times if you are running on battery, your device will underclock the CPU to conserve power. And that can affect the performance of the page. So like if you're running a game that was running at 60 frames a second, then you unplug it, and then the frame rate may drop to like 30 frames a second.
True.
So it not only can script execution drain your battery faster, but on battery, you could get poorer performance too. So it's always good if you're testing performance of things to test with it plugged in and also test with it unplugged and see if the performance difference and the performance characteristics of that.
Exactly. This is actually a very good tip. We're in the studio, so we cannot really unplug the power. But make sure when you go back to the performance test, plug it and do the test, take your benchmark, unplug it, and see what's the result. I could guarantee you're going to see pretty big difference. Okay, your target devices matter. So we live in a big world. How many devices we usually carry? We have desktop, maybe at home. We have laptop, maybe bring to work. We have a tablet. We have mobile device we use for fun or for work as well, right? So when you actually defining your particular performance criteria, you really have to think about what is your target device? Because an app could run perfectly on a desktop, because it has more resource, but then it could run really poorly, the performance could be really poorly on your low-end mobile device. So here, I want you to think about what is your performance criteria, what kind of end device you need to support. Hence, you could actually, according to the target device, you could write your application more efficiently based on the criteria.
I see this a lot when devs are doing and creating benchmarks on JSPerf. They'll do things like say, wow, it's millions of operations a second. But then when they go to the mobile device, it's thousands of operations a second or hundreds of operations a second. And then that gets down to really, really mattering on like a low-end mobile device versus your powerhouse desktop PC.
Very true, very true. Good point, because then think about your end user, what kind of device they're using. Don't just test it on your super fast computer and think everything's good. So this is another tip we want to share with you. All right. Okay, web runtime architecture. JD is an expert on that. So, JD?
Okay, cool. So this section is for the web runtime architecture. This is the flow or the pipeline of execution when you visit a page. So first, we're going to load something from the cache. The browser has to then parse the HTML and JavaScript and also CSS, and then break that down into a tree. From there, it's going to apply CSS if you've got things ordered correctly, execute your JavaScript, and then allow you to also operate on the DOM. When you're operating on the DOM and executing JavaScript, that can affect the formatting of the page and the layout of the page. And that will also affect the painting and composition. A lot of times, and we'll get into this in a later section, your JavaScript can cause the page to recalculate its layout and its format, and that can cost performance because it's having to sit there and iterate over the DOM tree and your markup and calculate all of the the bounding boxes and containers of your page. We'll get into ways to do that more efficiently. But the flow is, when you're working on a page, there's HTML, there's CSS, JavaScript, and it's more than just markup in your page. There's other things to consider, like the formatting, the layout, the painting. And then at the very end, it gets composed by the GPU and then rendered to the screen.
Yes, exactly. So the reason we want to actually share with you the detail of the web platform architecture is in the rest of the modules, we're going to actually talk about some of the tips or best practice. And we hope you could understand why those things are important, because it really correlates to different stage inside of this web platform architecture. For example, why we should not do extensive parsing, and why we have to work with DOM object more efficiently, and what's going to happen if we do this. What kind of container? Is it a JavaScript container we're working with by itself, or working with HTML or CSS? So all those things is actually part of this web platform architecture. And then also formatting matters, right? Because a lot of people didn't realize how important formatting is during this web runtime infrastructure. And then obviously towards the very end, we're going to actually do the composition, which is leave the GPU to do the work. And we're going to actually share with you some of the tips why it is actually a good idea to leave GPU to do more work than leave it to CPU. We will give you some example on that. Okay, so very good. So we talk about quite a few things. We talk about the process. You should really be aware. We talk about the common pitfalls you should totally avoid. We really also talk about some of the factors and some of the parameters, why those are important to measure web performance. We talk about web platform architecture. Now, another question people usually have is they always ask me, because nowadays, of course, we have traditional web developers, which is develop apps running on the browser, which we call websites. But then most of us also writing some apps on the devices, isn't it? Right? So we're actually writing different kind of apps to port onto different mobile device or tablets, right? So I actually want to share with you what's the difference, because people are really confused about it. They will say, okay, JD and you share with us a lot of good tips, best practice, and the tricks, and what should I do with that, right? And I would say all the things we shared with you will be applying to all the modern browsers, not just IE, but all the major modern browsers as well. So let's look at this kind of like architecture diagram. Hopefully you could understand it much better. So normally, as what we say, traditional web application, we talk about the green area here. This is the application. You use HTML, JavaScript, CSS to develop your app, and it's running in a browser. It could be IE, or it could be any other major modern browsers, right? So this piece is a website. And then, as long as you use HTML, JavaScript, CSS, you could actually also develop apps, which is native apps, running on Windows, right? So all the best practice, all the tricks, tips you learned today could also apply to those code which is written using HTML, JavaScript. The reason is they are running the same JavaScript engine, which is called Chakra. We will talk a little more about that later on. So, and because they're running the exactly same engine, so it's actually, you could say, I could even do something really smart, which is copy and paste your code from your website code, right? And then just HTML, JavaScript, and directly into the Windows app, and it will work. Because it's running well, say in IE 11, it will definitely running well on Windows 8. Right. So, and the other things you may ask is, okay, I understand that this is a Windows app. This is on the blue area in this diagram, right? So very nice. Then still, what I could do with a native Windows app? Well, with that, you could see, in addition to the regular, green area traditional website application, you could also access quite a lot of native library. For example, you could work with camera, you could work with file system, you could work with printing or some other devices. So it does give you better capability to write even more powerful apps. And again, yes, you could use HTML, JavaScript, CSS to make your native app. So hopefully that really answers your question about, what's the difference between a regular website versus what is a Windows app, which is a native application. Okay, so in summary, we talked quite a few things in this module. We talk about what will be a right way to attack your problem. You wouldn't expect me to tell you just exactly ABC, but you could use this optimization and development process to go through your code and to resolve your problem. And then make sure it is fit very naturally into your development cycle. Right? And then we talk about some of the common pitfalls you should be aware of. And I hope you could still remember a couple of them. If not, you could always go back to the slide. So things like do not guess, your manager will be different. We're going to actually address again in the rest of the modules. And then, of course, and you want to understand what to measure, right? So we talk about quite a few things. Networking. We talk about how to do memory management more smartly. We talk about CPU utilization, GPU utilization, UI responsiveness. And also, we talk about what exactly going on during the web runtime. And I also try to answer some of the questions, which is, what's the difference between a website or a native Windows app? So hopefully you all onto the same page. This is really a web performance kind of one-on-one introductory. And we're going to actually continue with that in more detail. So next module, we're going to talk about how you could measure the performance of your application, what kind of tools you would be using. So we're going to actually take a 10 minutes break from here, and we'll resume 10 minutes later. See you.